Hi everyone, I am Dr. Surjit Singh. Today I'll talk about the Leetcode problem, addition of two linked lists. Welcome to my video. Let us begin. We are given two linked lists that represent non-negative integers in the reverse order. We need to find the linked list that is their sum. First, let us spend some time on understanding the structure of linked lists. Linked lists are made of connected nodes. These nodes are made of two parts, val and next. Val is the digit stored in the node and next is the memory address of the next node. In this node, val is 4. Next stores the address of the next node. This linked list is made of three nodes. Val at the first node is 4. It knows the address of the next node at which val is 5. Val at third node is 8. Storing the memory address of a memory in another memory is called pointer. So, next part of the node with val equal to 4 points to the node with val equal to 5. In this linked list, we do not have backward links. Address of the first node is stored in a variable called head. Last node does not have any address in its next part, so we store none there. Head is used to access the linked list. We can reach the end of the linked list using links. Last node is called tail. We can use head to traverse the entire linked list. Let us now write a program to create a linked list from a given list. The given list is 263. We start with a temporary node called dummy head. We create an object and allocate free memory to set up this node. Initialize its value to 0 and next to none. This statement is the constructor of node. We save the address of this node in dummy head. We copy dummy head to another variable called tail, which means that both head and tail point to the same node at the moment, and they both store the memory address of this node. We now iterate over all the elements of the input list. We fetch a new node from the memory. The first value in the list is 2. We initialize val in the node to 2 and initialize next to none. We assign the address of new node to the next part of tail, which was previously assigned to none, and we assign the address of the new node to tail. In the second iteration, we fetch another node from the memory. The second element from the list is stored in val and we assign none to next and we save the address of this node in the next part of tail node. Then we point tail to the new node. And in the last iteration, the arrangement is like this. The list is now complete. We discard the extra node and return the address of the next part of dummy head to the main program, which is saved as head by the main program. So head points to the memory location of the first node in the linked list. Once we return from this function, the local variables of this function, including the temporary node, free their space. In most linked list problems, we are given the head of the linked list. Now let us traverse the linked list using head and convert it back to a list. We copy head into node and create an empty list result. We start a loop while node is not none and append the value part of the node to result and shift node to point to the next node. In the next iteration, 6 is appended to result and we point node to next node. And in the third iteration, 3 is appended and we point node to next, which is none. Therefore, the loop terminates, process is complete, and result is returned as the output list. It is helpful to keep this part of code handy before starting to write the solution class for any linked list problem. Now let us work through the problem of adding two linked lists. We are given the heads of two linked lists x and y. Our aim is to find a linked list which represents some of these two. We create a new linked list called dummy head containing a single node with value equal to 0. We copy this head to another pointer variable called node. We create a variable carry and initialize it to 0. We run a loop until either x or y is not none or carry is non-zero. In the first iteration, x val is 2 and y val is 5. Column sum is 0 plus 2 plus 5 equal to 7. We create a new node with value equal to 7. New value of carry is also 0. We will now store the address of this new node in next part of node. Variable node, which was pointing to dummy head, now points to the new node. We now point x to x next and y to y next. In the next iteration, x val is 4 and y val is 8. So column sum is 12. We create a new node with value equal to 2 and carry now becomes 1. We point node next to new node and then point node to new node. Then we point x to x next and y to y next. In the next iteration, column sum is 13. We create a new node with value equal to 3 and new value of carry is 1. We point node next to new node and then node to new node. Then we point x to x next, but y is pointing to none. In the fourth iteration, x val is 9, but y val is 0 because y is now none, and column sum is 10. We create a new node with val equal to 0, value of carry is 1. We point node next to new node and then point node to new node. X now points to none and y was already none. Both x and y are none, but loop continues because carry is not 0. Both x val and y val are 0, column sum is 1. So we create a new node with val equal to 1. Carry now becomes 0. We point node next to new node and then point node to new node. Both x and y are none and carry is 0, so loop terminates. Next part of dummy head points to the address of the resulting linked list, so we return that as the head of our result linked list. Loop runs for all the nodes in x and y, so time complexity depends on whichever is the larger of the two linked lists. No extra memory is used for saving the nodes, so space complexity is of the order of 1. However, space complexity of output is of the order of the larger of m and n because the output has m plus 1 nodes. Thank you for your time. Hope you enjoyed the video. Please share the video with your friends and subscribe to my channel.